is lesson 2.1, the remainder theorem. In your 2.0, we've already done some practice with long division. Essentially, we're going to be applying what we know about long division to polynomials, which means eventually we're going to be able to use some of these strategies to find factors for polynomials when no factors are given. Step 1, we're going to be able to find factors when we're already given a factor. Okay, so we're going to be able to divide it out. Another trick is also even determining whether or not the polynomial is factorable, or whether or not the factor given is indeed a factor of that polynomial. That's probably going way over your head. Let's just jump in and divide this thing out. So example 1, divide a polynomial by a binomial. We are given the polynomial. It says divide negative 3x squared plus 2x cubed plus 8x minus 12 by x minus 1. Okay, and the first step that we are going to use is we're going to be doing some long division here. So we've got we're going to write it just like you would regular long division back in grade 5. So you've got negative 3x squared plus 2x cubed plus 8x minus 12, and we're going to divide that by x minus 1. Okay? But before I do that, there's a problem here. One key thing that we need to know is, first thing we need to do is express it in descending powers. So I really shouldn't even have written this yet. You won't be able to do it written like this. So we're going to write step 1, express in descending powers of x. So rather than write that, I'm going to rewrite it because we need to swap some things around here. Underneath the division symbol there, we're going to have 2x cubed minus 3x squared plus 8x minus 12. And then throw our division sign in there and go x minus 1. You can leave what you have. You don't need to erase. I'm just getting it out of my way. And we're going to work through it step by step. I'm going to write the step in words on the right here, and we're going to do the work on the left here, and by the time we're done, we will have divided this polynomial. So first step is we're going to look at the first term in the binomial. Okay, it's going to be the term with the variable there. And what we're going to do is we're going to look at the first term there and the first term in the polynomial. And we're going to divide the first term in the polynomial by the first term in the binomial. So we're going to divide 2x cubed by x. Okay? Well, what happens when you do 2x cubed divided by x? 2x squared. The only thing that changes is the variables. You're dividing out one factor of x. So you end up with 2x squared. But look where you write it. You need to write it in the x squared column. Okay? You need to write it in the x squared column. So we've got 2x squared. Now, same thing happens as in long division. We're going to take that 2x squared and we're going to multiply it back down through the binomial. Okay?
That gets you with the exact same thing you started with.
So you've got 2x squared times x, which is 2x cubed. For this one, you will always get the exact same thing that you started with. Otherwise, you didn't do it right. Okay? This will always cancel out that term. Then we have 2x squared times negative 1, which is negative 2x squared. Okay? Same as long division. We're now going to subtract those two. You're right, this will end up being 0. But now we have negative 3x squared minus negative 2x squared. That's negative 3x squared plus 2x squared, which leaves you with negative x squared. And bring down the next term. I'm going to pause there to just write a couple steps of what we've done. Okay? What did we do? First thing we divided 2x cubed by x to get 2x squared. Record over the x square term. Then multiply 2x squared by x minus 1 to get 2x cubed minus 2x squared. Then subtract. Then bring down next term, which in this case is positive 8x. Now what do we do? We're just going to say repeat. So now we're looking for, we're taking this negative x squared, okay, and we're going to divide it by x, which is going to leave us with a negative, and it's going to leave us with one factor of x. So it's going to leave us with negative x. Again, writing it over top of the term with x's in them. And then what do we do? Well, we go back here. We're going to multiply back down through x minus 1. So our first term, if we did it right, we get negative x times x. That's negative x squared. That's good. And do this all in the same color. Negative x squared. And negative x times 1 is positive x. Now, same step. We're going to subtract. Negative x squared minus negative x squared is 0. 8x minus x is 7x. Bring down the next term, which is negative 12. And now we're looking at that first term in the binomial again. We're saying how many x's fit into 7x? Or 7x divided by x is
7.
And it's 7, positive 7. Multiply back down through x minus 1. So you end up with 7x minus 7, right? In this case, we end up with a remainder of negative 5, okay? Because we need to subtract through. Negative 12 minus negative 7 is negative 12 plus 7, which is negative 5. The remainder is negative 5. Okay, this is part A of example 1.
Doesn't feel right.
It's awkward, eh?
I don't think we got the right answer.
It becomes very useful later on. So what makes you think you didn't get the right answer?
It's just awkward.
It's awkward. There's a remainder. So it turns out that 2x cubed minus 3x squared plus 8x minus 12 doesn't divide evenly by x minus 1. X minus 1 is not a factor. Okay?
Yeah.
So if you drew this, if you graphed this out, it would not have an x-intercept at 1. Okay?
Yeah.
Ideally, we'd be using factors that are factors, and then you would divide it out and you'd get more factors, and then you could factor that out and you'd get all the factors. Okay, that's our goal. Right now we're just playing with it, and but part of part A here is to express the result in quotient form. Please make sure you have a note of this. Quotient form. Basically that means is you're going to take the original question that we got, and I'm going to put it back in its non-arranged powers of x, although you could keep it arranged in descending orders. But basically we have 3x, negative 3x squared plus 2x cubed plus 8x minus 12. We took that and we divided it by x minus 1. And we got 2x squared minus x plus 7 with a remainder of negative 5. Now pay attention to this remainder because you'll see it. This remainder of negative 5, well, look at what we did each step. Basically here, we multiplied it down to here and we got a remainder of negative 2x squared, and then we brought down this term and we divided those things by x minus 1. Each step, each piece of this polynomial has to get divided by x minus 1. Okay, so that's what we're doing in each step. First we divided this part by x minus 1, then we brought it down and we had a remainder, and we brought down the next thing and we divided that by x minus 1. Then we had a remainder, we brought down the next term and divided that by x minus 1, and by the end of it we still have a negative 5 which didn't get divided by x minus 1. It can't be divided by x minus 1. So what you actually still have here is a remainder of negative 5 over x minus 1. Okay, you have an amount that made it through the process and didn't get split up because it couldn't get split up. Okay, it couldn't be, this negative 5 couldn't be shared fairly among these groups. That's kind of how division works, right? It couldn't be shared. So you just have that remainder, but you don't actually have that many. It's still being divided by x minus 1.
Well, the calculator could probably give us.
Assuming you knew the value of x, the calculator could certainly give you an answer, but so could you if you knew the value of x. Okay, good. And in this case, we know that x is, anyway, we don't need to get into that. Good. This is quotient form. You will need to know that. You will get that on test. It will say record what you did in quotient form. Basically, rewrite the question in fraction form and then write the answer with the remainder that still needs to be split up. Right? This works the same in long division. If you divided 7 by 2, you would get 3 remainder 1, which is actually 3 1/7. 7 divided by 2 is 3 1/7. Okay, that 1 has to get split up into 7 equal parts. Make sense?
Yep.
Good. Okay, step B says identify any restrictions on the variable. Basically, what we need to remember is that division by 0 is undefined. So this, what you divide by, in quotient form, the denominator here, cannot equal 0. So in B, we're going to say since division by 0 is undefined, comma, since division by 0 is undefined, x minus 1 can't be 0. Add 1 to both sides. X can't be 1. All right, you have quotient form. And in C, we come up with what's called the corresponding statement. C, corresponding statement. The corresponding statement, if the quotient form is expressed as a quotient, numerator over denominator, the corresponding statement looks more like factored form, looks more like multiplication, but it's the same thing. Basically, if the top divided by the bottom is the right-hand side, then the top is the bottom times the right-hand side, right? This times this equals that. It's basically what you get into. It's a division triangle to get your corresponding statement. So here we're going to write the left side, which is our original polynomial, negative 3x squared plus 2x cubed plus 8x minus 12. And that is equal to the fraction that we used to divide by, that's x minus 1, times 2x squared minus x plus 7. And look what happens here. If you're multiplying every term on this side by x minus 1, you can do these three in a group like that, but what happens to this last term if you multiply it by x minus 1?
It's just going to multiply it by the bottom, and you'll have just straight -5.
You'll just have -5, which is nice. It's just your remainder. So once you end up with a remainder in your long division, you know that it's just your answer times your dividend plus your remainder. That's your corresponding statement. Okay? And D says verify your answer. Basically, to verify your answer, you just do the expansion on this. Okay? So to verify your answer, I can probably fit it in the space that we have. I'm just going to switch colors.
We can give ourselves a D. Verify your answer.
Verify basically just means expand it all. Okay? So this binomial times that trinomial, and then subtract 5. So it looks like this. X times 2x squared is 2x cubed. X times negative x is negative x squared. X times 7 is positive 7x. And then I can work on my next term from the binomial getting multiplied, distributed to all the terms of the trinomial. Basically it's -1, so it's just going to flip the sign of each of these. So you've got negative 2x squared plus x minus 7, and then you have your remainder, -5 at the end. Group like terms. We have 2x cubed, that's our only term with x cubed. We have negative 3x squared. We have positive 8x minus 12 as a constant at the end. And you can rearrange this to make it look exactly the same as the one that we started with, but you should be able to see it is exactly the same as the one that we used in our division, okay, after we expressed it in descending powers of x. So that checks out. What did we do? We took a polynomial, divided it by a binomial, okay? We ended up with a remainder. We learned how to express it in quotient form and expressing it the corresponding statement. You can verify using the corresponding statement by just multiplying it out. And we also had a reminder that division by 0 is undefined, so there are restrictions to this situation. Okay, x cannot be 1 in this case. In example 2, the binomial that we are dividing by has a coefficient in front of the x term. So we're going to figure out what to do with that. So we've got our polynomial. It's already written in descending powers of x. Don't rewrite it. I'm just rewriting it to get it down here. We have to do something to it first. Now you remember from the first example that we had to line up our x cubed terms and our x squared terms and our x terms and our constants. But what do you notice about this trinomial?
There are none of those. We just put 0x squared plus 0x. Just 0x squared.
Yeah, there is no x squared term. So we actually need a placeholder. Okay? Since there is no x squared term, comma, we need the placeholder 0x squared. Okay, so now we can write our division. We've got 4x cubed plus 0x squared plus 9x minus 12. That's in descending powers of x. And we're dividing by 2x plus 1. Now, what is different about dividing by a binomial with a coefficient in front of the x term that's not 1? Nothing's really different. You're going to follow the exact same steps. Okay? So exact same steps. Step 1, I'm going to write them out again systematically. Divide 4x cubed by 2x. Okay, so you're only looking at the first term of your polynomial, and you're always only looking at the first term of your binomial. That's when you're dividing. Okay, So what do we end up with if we take 4x cubed and divide it by 2x? Well, the coefficients, you divide 4 divided by 2. And by the way, we're going to end up in the x squared column. 4 divided by 2 is 2. X cubed divided by x, you just take out a factor of x. You end up with 2x squared. Next step, Natasha. Okay, put a little x there if it's helpful for you. Multiply 2x squared by 2x plus 1. And we end up with 4x cubed, thankfully, plus 2x squared. And now we're going to, let us color coordinating our steps here. We're going to subtract. Subtract. 0 minus 2. It's negative 2x squared. Subtract and bring down positive 9x. And repeat. How many times does 2x go into negative 2x squared? Goes in negative x times. And multiply back down in purple. Negative x times 2x is negative 2x squared. Good job. Negative x times 1 is negative x. Subtract. 9 minus negative 1. 9x plus x, that's 10 x's. Bring down negative 12. How many times does 2x go into 10x?
5 times.
5 times. Purple, we multiply back down. End up with 10x plus 5. Common error here is to say, oh, I'm done, remainder 7 or negative 7. Okay, don't do that. Finish it out. Negative 12 minus 5. It's negative 17. Okay, so in this case, we have a remainder again. The new thing that we learned is to put a placeholder in there. And even though it has a coefficient greater than 1 in front of the x, you still just complete it the same way, step by step. And now we need to write it in quotient form and identify restrictions and write a corresponding statement. So, quotient form. I'm going to just, you won't have to write this word if you're doing your practice problems. I just want to keep on reminding you, and so that when you look back at your notes, you can find it in like 3 spots when you forget what it is. Quotient form. 4x cubed plus 9x. Notice I don't need my placeholder here anymore. Plus 9x minus 12 over 2x plus 1 was equal to 2x squared minus x plus 5. And your remainder is always going to be plus, and then a fraction, negative 17 over 2x plus 1. That's the amount that's left over that couldn't be split evenly by this group, 2x plus 1. I'm going to do the corresponding statement first and then restrictions. I guess, no, I should do the restrictions because they go with quotient form. So you can clearly see there's a denominator here. So restrictions. Restrictions are that 2x plus 1 cannot equal 0 because division by 0 is undefined. So subtract 1 from both sides. 2x cannot equal negative 1. Divide both sides by 2. X cannot equal negative 1/2. Corresponding statement. corresponding statement is we take our original polynomial, 4x cubed plus 9x minus 12, and it is equal to 2x plus 1 times 2x squared minus x plus 5 minus 17. Again, you just need a placeholder if you're missing a term. If you're missing two terms, you need two placeholders. Okay? So that you can line things up properly, because as you divide, what's going to happen is you're going to create an x squared term, right? So if we didn't have a placeholder here, this x squared term would end up being with the 9x's, and you can't add and subtract x's and x squareds. They're totally different. Okay, so you need that placeholder for every power of x descending from the greatest one, which is given in your original polynomial. Anyway, add a placeholder, divide out the same way, be very careful, quotient form restrictions, corresponding statement. Example 3 attempts to take this strategy into the real world-ish, and we're talking about the volume of a rectangular box, and we're told that the volume is represented by, get that out of the way, the volume is represented by the polynomial equation v of x equals x cubed, that makes sense that it's a cubic because it's volume, plus 7x squared plus 14x plus 8. And we are told to determine the possible dimensions of the box if the height of the box is represented by the binomial x plus 2. Okay, what are some things we know about volume? We know that volume is length times width times height.
If you take away the height, then you just get the square or rectangle.
Right, so if you divided your volume, if you divided both sides by h, okay, you would end up with the factor LW. So V over H is going to leave you with LW. And then you can factor that again, because that will just be a quadratic, which you can factor using sum and product. Okay, so that's our goal. Basically, they're giving us one of the factors, and once you're down to two factors, you can use sum and product, assuming each of those factors only has one power of x in it. All right, so here we go. We are going to divide the volume by the height. So here's our volume. X cubed plus 7x squared plus 14x plus 8. I double check to see, yep, it's arranged in descending powers of x, and I don't need any placeholders because all the terms are there. I'm going to divide that by x plus 2. From here I'm going to work fairly quickly because we're just doing the same strategy. So I'm going to look at my x cubed term, divide it by x, that's going to leave me with x squared. Multiply that back down, I get x cubed plus 2x squared. Subtract it. 7 minus 2 is 5x squared. Bring down. And you'll be able to do this quickly as you move through, but please double check that you're not making silly mistakes, adding and subtracting mistakes, things like that. Now we're looking at 5x squared, dividing it by x. We end up with 5x. Multiply that through, I get 5x squared plus 10x, subtract, leaves me with 4x, bring down positive 8, and divide that, 4x by x leaves us with a factor of 4, multiply that down, I get 4x plus 8, subtract, I get a remainder of 0. What does a remainder of 0 tell me? It tells me that x plus 2 does divide this polynomial, and in this case it tells me that I will be able to find the other factors. I won't have a remainder. If you had a remainder, then x plus 2 wouldn't even be a factor, which means height couldn't be x plus 2. Okay? Yeah. In this case, obviously it does because they told us that it works. So we can now express, if I just rewrite, we can express x cubed plus 7x squared plus 14x plus 8 as x plus 2 times x squared plus 5x plus 4. Okay, that's not a surprise. That's our corresponding statement that we've written already a couple times. Now, our goal is to find all of the possible dimensions. We haven't done that so far. We have a product of length and width because we factored out our height. But now I notice that I actually have a trinomial, a quadratic, and I can factor that out in one more step. Okay, so then all you're going to do is factor what's remaining. Basically what we're saying is if this is the height, then this is the area of the box, the area of the bottom face.
Rectangle.
It's just a rectangle which has length and width. So we can factor that out. Okay, how do we factor that out? We use skills that we already have. We're looking for two numbers that add to 5 and multiply to 4. That's 4 and 1. So our factors then are x plus 4 and x plus 1. What were we actually asked to do? Determine the possible dimensions. Possible dimensions for...
This is just the dimensions that happen to be like whole numbers. It's probably like an infinite amount that aren't whole numbers.
Well, x can still be anything. So as long as the box stays proportionate, kind of, if I can speak in those terms, x could still be a decimal. So the height could still be a fractional number. Yeah. But it only works out dividing it out to get factors that actually divide without a remainder. Possible dimensions for the box are, comma, in centimeters, x plus 1, x plus 2, x plus 4. And you could also do, for instance, you could put restrictions on this. It doesn't talk about them, but restrictions, you can't have a negative length, right? So x must be greater than negative 1. Okay, if x were negative 1, then you would have a dimension of 0, in which case you wouldn't have a box, right? If x were less than negative 1, you would have a negative volume, which is nonsense. But if x is negative 1 or greater, sorry, not negative 1, if it's greater than negative 1, you'll always have some volume in this box. It will still be a box. Okay? There we have it. Real world application. They gave us one of the factors in our volume. We divided it out to find a product of the other two factors, and then we used our basic skills to find out the last two factors. So you can do this with an even bigger one. You can, factor out one factor and then factor out another factor, and by the time you get to a quadratic, you can use your traditional factoring skills to finish it off. Okay?